Hello, this is Ms. Cliffner with your lesson for Tuesday, January 25th. The essential question is, how can we use algebra tiles to model factoring expressions? Take out your planner and write down the homework. It's extension 3.4. It's a worksheet that you're going to glue in. But if you're working at home, if you don't have a printer, you can just write out the problems in your graphing notebook or your math notebook. I'm still talking about the worksheets that I'm going to be checking this week, and we're going to be doing the new set of classroom jobs. So today we're going to be, again, looking at the distributive property. It's just going to look a little bit different than what we've been doing. Okay, so here's the warm-up. I want you to simplify the fractions, and the easiest way to simplify is to divide out or to think about dividing out the greatest common factor. So go ahead and pause the video and try to simplify. Remember, what we're doing is we're dividing by a giant 1, the same number in the numerator and the denominator. If you have a yellow sheet, right, we've got common factors on the yellow sheet. Okay, so 2 and 12 are both divisible by 2, so I divide by a giant 1, which is 2 over 2, and then I go across. 2 divided by 2 is 1, 12 divided by 2 is 6. All right, I have 3 and 9. The common factor is 3, so I divide by 3 over 3. 3 divided by 3 is 1, and 9 divided by 3 is 3. These are both divisible by 2 because they're both even. I divide by 2 over 2. 4 divided by 2 is 2, and 10 divided by 2 is 5. Now this is an improper fraction, so you totally could think of it as how many times 5 goes into 10. But if we want to just keep dividing by the greatest common factor, they both share 5 as a factor, so I can divide by 5 over 5. 10 divided by 5 equals 2. 5 divided by 5 equals 1. And of course, 2 over 1 is just equal to 2. Okay, so that's a quick review, and the reason that I'm reviewing greatest common factors is that really is the idea that you can use today to do the opposite of distributing. Okay, so here is the answer key to the homework from yesterday. I did number 1 mostly in class with everybody, so this is what number 2 looks like. So notice that here I drew 2 groups. Here's one group of 2x minus 1. Here's a second group of 2x minus 1. And then when I put the like terms together, I now have 4x minus 2. And then the last one, there was 1, 2, 3, 4 equal groups of 2x plus 3. And then when you combine the like terms, it's 8x plus 12. But I want you to see the connection, right? What I'm doing is I'm doing 4 times 2x plus 4 times 3. That's what we have right here. 4 groups of 2x equals 8x because I multiply the 4 times 2 together. And then 4 times 3 is just the 12. So we're trying to see what's happening with the distributive property when you can actually see the things that are being multiplied. Okay, so now today I'm going to tell you when we use the distributive property, right? This is from the song, multiply the outside by the in. But today we're going to use the distributive property and we're going to work backwards. So the opposite of multiplying is something called factoring, and factoring involves division. So we're going to be making equal groups. Instead of looking at the groups and then combining like terms, we're going to do the opposite. We're going to make equal groups. So we're going to divide out common factors. So distributing is multiplying and factoring is dividing. So we've been practicing multiplying with algebra tiles. Now we're going to be practicing dividing algebra tiles. Okay, so this is just our key from the other day. I didn't change it up. It's the same exact. When you see a rectangle, it's x. The filled in square is 1 and the empty square is minus 1. Okay, so this is an example from yesterday, but now I've turned it around. And, oh, sorry, this was what you saw yesterday, and the next slide is going to be turned around. So notice that this was 2 groups of 2x plus 3 because it's the 2x that I see here plus 3. So both of these groups have a 2x plus 3. And then when I group the x's together, it turns out I have 4x. And when I group the 1's together, I have 6. So the idea is, once you've got that picture in mind, today I'm going to be giving you a whole set of algebra tiles, and I'm saying now I have grouped the like terms together, and it's going to be your job to figure out how many equal groups you can make, right? So what I'm doing is I'm looking at the numbers. I'm really going to be focusing on, I have 4 things and I have 6 things, and I'm already thinking, wait, if I have a 4 and a 6, they're both even numbers, so they're divisible by 2. So it kind of makes sense to look at the coefficient and the constant, those 2 numbers, and see what they have in common. And since they both share 2, right, that's, and it turns out not only is 2 a common factor, it's the greatest common factor. So that's what leads me to think about making 2 groups of 2x plus 3. So we're working backwards this time, and I'm going to give you an expression like this, and I'm going to ask you to come up with the number of groups and then the parentheses of the thing that is inside the groups. Okay, so now I'm going to show you a couple examples from yesterday and working backwards. So this picture here yesterday was on the right hand side. And this is, it looks like, let's see, 1, 2, 3, 4, 5, 6, right? If I draw this expression, it's 6x minus 3. Now what I want to do is I want to think about how I can group these things together and make equal groups. And so hopefully you're thinking about the 6 and the 3, both share 3 as a common factor. And so even though I don't have these pieces that I can move around right now, what I do is I sometimes draw on it. So I'm thinking of making 3 groups. And if I only have 3 things here, that means one of these has to be in each group. So it kind of makes sense to go like this. What if I group one of these squares and 2 of those x's, which leaves this one square to be grouped with these 2 x's, and then this third square gets grouped with these 2 x's. And so when we work backwards, we figure out that, yes, there are 3 groups. 3 is on the outside, and on the inside is 2x minus 1. And I can check it by distributing and making sure I get the same answer that I have over there. 3 times 2x is 6x. 3 times minus 1 is minus 3. So today, you're going to see all the terms, the like terms are grouped together, and we're going to try to make groups by dividing them into equal groups. And here's another example from yesterday. And notice if I write the expression, I always want to write the expression first if it's not already there. I have 3, 6, 9, 12. I got 12 x's plus 5, 10. And I know that 12 and 10 are both divisible by 2. So I'm kind of thinking what's going to be over here is 2 groups of, well, if I divide this number by 2 and divide this number by 2, half of 12 is 6. So now I've got 6 x's. Half of 10 is 5. So this is hopefully what the picture is going to look like. And when I move that away, you can see that, yes, yesterday we looked at 2 groups of 6x plus 5. Okay, so now these are my steps for factoring expressions using algebra tiles. So you want to draw the algebra tiles if you don't already have a picture there. I think I gave you all pictures today to help you out. But you could totally make your own key. You can change it up as long as you're consistent with what you decided to represent the x's or the y's. Then you're going to find the maximum number of equal groups, and I'm telling you that you can use the greatest common factor. So you look at the 2 numbers that you're seeing, only 2 numbers where there's a coefficient and a constant, and so there's x's and then there's 1's, and you need to make them into equal groups using the greatest common factor. And then you're going to redraw the algebra tiles showing the equal groups, right? Just because I want you to see the picture and how it matches the algebraic expression. And then you're going to rewrite that expression with parentheses. The number of groups is the multiplier. You know, I often call it the multiplier. It's the number that's on the outside of the parentheses. It tells you how many groups to make. Okay. I've got one example and one OYO. So here's my example. It's 4x plus 10. Now, I already drew this for you, right? So I put it like right here. on the homework sheet and in your notes. So I already drew 4x plus 10. So I'm thinking, I'm looking at the 4 and I'm looking at the 10. I have 4 of those x's and I have 10 of these. Now, if I had the little separate pieces, right, I could play around with these. So this is why I have these on my paper. I'm going to move this down here and I'm going to grab 1, 2, 3, 4 x's and I'm going to grab 10 of these. So the cool part about having pieces that you can move around is it's a little bit easier to picture. Okay, so now I've got 4x. So I'm already seeing, like, if I separate these, right, there's 5 on the top and 5 on the bottom, that's 2 groups. Well, I can drag this over here. So now I've got one group of 2x plus 5. And on the bottom, I have another group of 2x plus 5. And I was thinking that I know that 2 is the greatest common factor between 4 and 10. So this kind of makes sense why it's going to be 2 groups. So sometimes it's not that easy. And then what I'm going to show you is I'm going to move these out of the way by grabbing these. Okay, so let's get rid of all those and let's erase this and let's bring this back up here. So what I try to do is if I don't have pieces that I can move around, I start thinking, how can I draw circles around these? So I'm noticing right here that I've got 2 x's and I can take the bottom 5 and group those together. And then I've got the top 2 x's and the top 5 ones. So that's one way that I start to try to draw the picture. Okay, so I'm going to write the expression 4x plus 10. I'm going to redraw the picture from the groups. So now this does take a little bit of drawing, right? So I've got my 2 x's together and then I've got 5 ones. So maybe this time I'm going to do the ones vertically. Okay, so I have 1, 2, 3, 4, 5. There's 2x plus 5. I'm going to go ahead and circle those together. I need one more group of 2x plus 5. And I just like to make my groups, you know, sort of look the same. It's not perfect, right? Because I'm just writing on my computer. All right, but I made a second group of 2x plus 5. So I've got 2 groups. And what's on the inside is 2x plus 5. So this is the equivalent expression. This is grouped with like terms. This is now technically not simplified. It's factored. I divided out a 2. So now 2 is my common factor. And when I check my work and I go in this direction, 2 groups of 2x matches the 4x. 2 groups of 5 matches the 10. That's how I know this 2 times 2x plus 5 is correct. Okay, now we have an OYO. So here is your OYO. I want you to go ahead and pause it. I tried to make one that is pretty easy to figure out. Remember, you should probably focus on you've got 9 things and you've got 6 things and you want to put them into equal groups, right? So that the same thing is in each group. Okay, so I'm thinking that 9 and 6 are both divisible by 3. So it makes sense that it's probably going to be 3 groups. So what I'm going to do on this picture is I'm going to, see, I have 1, 2, 3 columns. And then down here, I see all those 6 negatives together. So it seems like if I divide 6 by 2, right? So I'm basically, divide 6 by 3. I'm dividing by 3 and I'm dividing by 3. So 9 divided by 3 is going to be 3 and 6 divided by 3 is 2. So I'm putting 3 x's and 2 of the negatives in each of these groups. Okay, so there's my groups and I'm going to draw the groups over here where I show that there's 3 x's grouped together with 2 negative ones. Here's another set of 3 x's with 2 negative ones below it. And here's my third group. Now, I I like to circle mine. Ooh, sorry. My x's are just getting crazy. They don't look the same at all. There's 3x minus 2. There's 3x minus 2. And there's a third 3x minus 2. So 9x minus 6 can be rewritten. The equivalent expression is 3 groups of 3x minus 2. So here is what the homework looks like. Notice on the first one, I drew the groups for you so that all you have to do is write what the expression is. And then notice I drew the picture on the left-hand side, but you need to redraw it with the groups. So remember, focus on, you've got 3 things and 9 things, 2 things and 12 things. So basically the idea is to find the greatest common factor by making, that's how you make the maximum equal number of groups. And then there's 2 more problems on the homework. And notice I just switched the order here. I did the 10 ones first, and then I did the x's afterwards. So good luck.